Good day everyone, my name is Ivo Miles Baito and together with my groupmates Sherri, Dela Cruz, Jalel, Monsales, and Jascha Tabar, we will be discussing Unit 8 Earthworks. This unit will consist of the following: 8.1 Introduction to Earthworks, 8.2 Average End Area Method, 8.3 Prismoidal Formula, and 8.4 Prismoidal Correction. Earthworks is the construction of large open cuttings or excavations involving both cutting and filling of material other than rock. Earthworks are required for many types of construction such as roads and railways, dams, tunnels, and buildings. It involves the loosening, removal, and handling of earth quantities in the construction process. Surveyors are often called on to determine volumes of various types of material. Direct volume measurement is uncommon in surveying because it is difficult to relate a unit of measurement to the material involved. In order to achieve indirect measurements, lines and areas with a link to the required volume are measured. There are three principal systems to measure volume. First is the cross-section method, second is the unit area or borrow pit method, and third is the contour area method. In this unit, we will only be discussing the cross-section method. The cross-section method is employed almost exclusively for computing volumes on linear construction projects such as highways, railroads, and canals. Cross-sectioning consists of observing ground elevations and their corresponding distances left and right perpendicular to the center line. Readings must be taken at the center line, at high and low points, and at locations where slope changes occur to determine the ground profile accurately. This can be done in the field using a level rod, and tape. After cross-sections have been taken and plotted, design templates are superimposed on each plot to define the excavation or embankment to be constructed at each cross-section location. Areas of these sections, called end areas, are obtained by computation. Here are some of the types of cross-section method. First is the level section. This is used when ground is level transversely. This is suitable for flat terrains. Second is the three-level section. In this case, the transverse slope of the ground is not uniform. Next is the five-level section. This may apply on terrains with rough topography. And last is the side hill section. This is used when dealing with side hill locations. Volumes are determined by the average end area or Prismoidal formula. The end area formula is simpler and requires less field measurement, so it is often the formula of choice. In some cases, end area volumes can be corrected by applying Prismoidal correction. The Prismoidal formula applies to volumes of all geometric solids that can be considered prismoids.
Hello everyone, I'm here to discuss about the average end area method. It is a useful tool for estimating quantities in construction. It is an approximate method for calculating the volume of earthwork between two cross-sections. We can see here in figure 1, it illustrates the concept of computing volumes by the average end area method. In the figure, A1 and A2 are end areas at two stations separated by a horizontal distance L. The volume between the two stations is equal to the average of the end areas multiplied by the horizontal distance L between them. To solve for the volume of earthwork between two cross-sections using average end area method, we have VE is equal to the average of the end areas A1 plus A2 over 2 multiplied by the horizontal distance L over 27. Equation 1.A is used when our VE, average end area volume, is in cubic yards, A1 and A2 are in square feet, and L is in feet. Another equation we can use is VE is equal to A1 plus A2 over 2 multiplied by the horizontal distance L. This equation is used when our VE, average end area volume, is in cubic meter, A1 and A2 are in square meter, and L is in meter. Equation 1.b also applies to computing volumes VE in acre feet, where A1 and A2 are in acres and L is in feet. Furthermore, if L is 100 feet as for full stations in the English system of units, equation 1.a becomes VE is equal to 1.852 multiplied by the sum of A1 and A2. To understand more about the average end area method, we have a sample problem here which is asking to compute the volume of excavation between station 24 plus 00 with an end area of 711 square feet and station 25 plus 00 with an end area of 515 square feet. For the given, let us solve first the horizontal distance L, which is equal to the difference between the two stations, so L is equal to 25 plus 00 minus 24 plus 00, which is equal to 1.00. So our horizontal distance L is equal to 100 feet, A1 is 711 square feet, and A2 is 515 square feet, as stated in the problem. For our solution, we can make use of equation 1.a, where VE is equal to A1 plus A2 over 2 times horizontal distance L over 27. And substituting our given, we have VE is equal to A1, which is 711 square feet, plus A2, 515 square feet over 2, multiplied by the horizontal distance 100, which is 100 feet, over 27. And using a calculator, we can solve our average end area volume, which is equal to 2,270.37037 cubic yards, or 2,270 cubic yards. And since our horizontal distance L is equal to 100 feet, we can also make use of equation 1.c, which is VE is equal to 1.852 multiplied by the sum of A1 and A2. And substituting again our givens, we have VE is equal to 1.852 multiplied by the sum of A1, which is 711 square feet, plus A2, 515 square feet. And using the calculator, we have our average end area volume is equal to 2,270 cubic yards, which is the same value of what we solved using equation 1.a. If the volume that is given is comprised of several sections, we can solve this by summing up all the average end area volume of each section, so the equation becomes V is equal to the summation of A1 plus A2 over 2 times the horizontal distance L. To understand this further, we have another sample problem which states that, given the table of data below, calculate the total volume of material to excavate/fill the area. So we are given, as seen in the table, that station 1 plus 30 has an area of 500 square feet, station 2 plus 10 has an area of 440 square feet, and station 3 plus 40 has an area of 520 square feet. And here in the right side, we can see the illustration of each station. Since this material is comprised of several sections, we can solve for the total volume using equation VE is equal to the summation of A1 plus A2 over 2 times horizontal distance L. Substituting the given we have in this first part, we are solving for the average end area volume between station 1 plus 30 and station 2 plus 10. So we have A1, which is 500 square feet, plus A2, which is 440 square feet, over 2 multiplied by the horizontal distance between the two stations, so L is equal to 210 feet minus 130 feet. And now here in the second part, we are solving for the average end area volume between station 2 plus 10 and station 3 plus 40. So now our A1 is equal to 440 square feet plus A2, which is 520 square feet, over 2 multiplied by the horizontal distance between the two stations, where L is equal to 340 feet minus 210 feet. And input this whole equation in the calculator, we get the total volume, which is equal to 100,000 cubic feet. Therefore, the total volume of material to excavate/fill the area is equal to 100,000 cubic feet.
Hello everyone, I'm here to talk about the Prismoidal Formula. So prismoids may be decomposed into the basic geometric solids, prisms, pyramids, and wedges, and the volume of a prismoid is obtained from the Prismoidal Formula. A prismoid, as illustrated here in the figure, is a solid having ends that are parallel but not congruent, and trapezoidal sides that are also not congruent. Most earthwork solids obtained from a cross-section data fit this classification. However, the differences in volumes computed by the average and area method and the Prismoidal formula are usually so small as to be negligible. Where extreme accuracy is needed, such as in expensive rock cuts, the Prismoidal method can be used. So as illustrated here in the formula, it states that the volume of any prismoid is equal to 1/6 its length, so 1/6 of its length, multiplied by the sum of the two end areas plus 4 times the mid areas. So the two end areas, A1 and A2, plus 4 times the area of the midsection. To further understand how to use the Prismoidal formula, I have an example problem that applies the formula. So the problem states that we have to complete the following notes and compute for the volume using the Prismoidal formula. The roadbed is level, the base is 30 feet. This note is an example for a 3-level cross-section. This one here represents for the left side of the cross-section. The values here represent for the center, and the values on the right represent for the right side of the cross-section. Now the values in the numerator represent the height. For 3.1, this is the height in the left side. 4.9 is the height in the center, while 4.3 is the height in the right side. The denominator represents the width. 24.3 is the distance in the left side. 35.2 is the distance in the right side. Now, to use the Prismoidal formula, it is necessary to know the area of the section halfway between the stations A1 and A2, meaning the halfway station of station 89 and station 88. Now this is found by averaging the heights and widths of the two end sections. Now we have to get the average height and widths of station 89 and station 88 to get the area of the midsection. Obviously, the middle area is not the average of the end areas, since there would be then no difference between the results of the end area formula and the Prismoidal formula. So now let us find the average heights and widths of the two end sections. So we all know how to get the average of two values. We just have to add 3.1 and 6.4 and divide it by 2, which will then be getting 4.75. Now we have to get the average of the width by adding 24.3 and 34.2, which will give us 29.25. So we get the average for the center and the right component. We get 4.25, 0, 5, and 33.65. So how do we find the area for a 3-level section? So given here is a formula on how to find the area of a 3-level section, where C is the height of the center, DL is the distance left, DR is the distance right, B is the base, HL is the height left, HR is the height right. So using the formula, we can now find the areas of each cross-section. Now for the first end section, we just have to input the values to the formula. 4.9 here is the height in the center, which is C. 24.3 is the distance left. And 35.2 is the distance right, all over 2, plus 30, which is the given base, times the sum of height left and height right, which is 3.1 and 4.3. We input these values into our calculator and we get the value 201.275 square feet. Now for the area of the midsection, you just have to input again the values from the notes. 4.25, which is the height of the center, 29.25, which is the distance left, 33.65, which is the distance right, all over 2, plus the base, 30, times the sum of the height left and the height right, all over 4, which is equal to 206.7875 square feet. For the last end section, you just have to do the same process. 3.6, which is the height of the center, 34.2 and 32.1, which is the distance left and distance right respectively, all over 2, plus the base, 30, times 6.4 and 5.7, which are the height left and height right, all over 4, which is equal to 210.09 square feet. Now we know the three areas of each section. So using the formula, we now have A1, now using the formula, we now have A sub 1, A sub m, and A sub 2. All that's left is L, which is the length. So how do we find the length? We just have to subtract the end areas. So the station 89 minus 88, which will give us 1, which is equal to 100 feet. Now we just have to input these values into the Prismoidal formula. To get the volume, we have 100 feet for the length, A sub 1, which is 201.275 square feet, plus 4 times the area of the midsection, which is 206.7875 square feet, plus the area of the end section, which is 210.09 square feet, all over 6 times 27 cubic yards. Now we input this in our calculator and we get the answer 764.515 cubic yards. So that is how you find the volume using the Prismoidal formula.
Hello everyone, I am going to discuss the volume with Prismoidal correction. This is the difference between volumes computed by the average end area method and the Prismoidal formula. The Prismoidal correction provides an accurate result for 3 level sections. So the formula is Cp is equal to L over 12 times C1, this is from area 1, minus C2 from area 2, and width 1 from area 1 minus width 2 from area 2. So we use Prismoidal correction because the average end area method always overestimates the volume. Therefore, the Prismoidal correction is generally subtractive. So the formula is corrected volume equals to the volume obtained from the average end area method minus the Prismoidal correction. So to fully understand Prismoidal correction, I have here an example. So the problem is we have to compute the volume using the Prismoidal formula and the average end area method for the following 3 level sections of a roadbed having a base of 24 feet. So we have here station 12, station 12 plus 50, station 13, and each station has its corresponding data. So we have to fully understand the given data, and I have here a diagram of a 3-level cross-section. So we imagine that each station has this figure or this diagram. L here stands for left, C stands for center, and R is for right. So in the diagram, this is the left portion and this is the right portion. L is height left over distance left, and C is the center over 0 because it doesn't have a distance. R is height right over distance right. So this is applied to all stations. So we have here station 12. So cut 7.8 is the height left all over 23.7 distance left. Cut 5.3 is the center over 0, and cut 7.4 is height right over distance right. So just apply it to all stations and we can understand where this data came from. So we now understand what these data stand for. It's time for us to go back to the problem that we have to compute for the volume using the two methods discussed earlier. So for the average and area method, VE is equal to A1 area 1 plus area 2 over 2 times L over 27 cubic yards. Prismoidal formula is VP equals to L times area 1 plus 4 times area of the midsection plus A2 all over 6 times 27 cubic yards. So as you can observe from the formulas, we cannot solve the volume unless we have the areas of each station and the value of L. So to compute for the area of each section, we have here the formula of a 3-level section. This is area equals to the center times distance left plus distance right all over 2 plus the base, that's given 24 feet, times height left plus height right all over 4. So for station 12, that's area 1, we have 5.3, this is the center, that's the center, times distance left 23.7 plus distance right 23.0 all over 2 plus the base 24 times height left 7.8 plus height right 7.4 all over 4, and then we just have to put it in our calculators, and we have 214.955 or 215 square feet. So to avoid confusion, distances are all in the denominator and heights are on the numerator. So station 12 plus 50 area of midsection is equal to center 6.0 times distance left 21.8 plus distance right 23.2 all over 2 plus base 24 times height left 6.5 plus height right 7.5 all over 4, and we solve it, we have 219 square feet. Station 13, area 2 is equal to center 6.6 times distance left 24.8 plus distance right 23.5 all over 2 plus base 24 times 5.8 height left plus height right 7.0 all over 4 is equal to 236.2 square feet. Okay, now the areas are all complete. We have to solve for L. We just have to subtract station 13 and 12. So we have here 1 or 100 feet. So the requirements are all complete. It's here in the upper portion for an easy access of the data we computed. And we can now solve for the volume of the cross-section. So we start off with the average end area. We have A1 215 plus A2 236.2 all over 2 times L 100 over 27, and that's 835.6 cubic yards. Prismoidal formula, L is 100, area 1 215 plus 4 area of the midsection 219 plus area 2 236.2 all over 6 times 27, and that's 819.2. Since we know that the average end area overestimates the volume, we will use the Prismoidal correction in order to obtain a more accurate result. So to solve for the Prismoidal correction, CP is equal to 100 feet times 12 over 12 times 27 times C1 5.3 minus C2 6.6 times width, which is the addition of left and right per station. So width 1 is station 1, distance 23.7 plus distance 23.0 minus width 2, distance 24.8 plus distance 23.5. So we have to compute it. Just put it in your calculators, and we have 0.6 cubic yards. So we can now get an accurate result because we have the Prismoidal correction. We can correct the volume from the average end area by subtracting the Prismoidal correction. So this is what we computed before, the average end area volume. So 835.6 minus the Prismoidal correction, it is equal to 835 cubic yards. So this is now the correct volume of the given 3-level cross section. And that's all for Unit 8 Earthworks. We hope you learned something from us. Thank you very much.